So every quadratic or equation that has x squared will have a graph that's a parabola. A parabola is a U shape that either opens up or opens down, and I'm going to talk about how to figure out which way it opens. And because it's always this U shape, there's always a lowest point or a minimum if it opens up, or a highest point or a maximum if it opens down. And this point is called the vertex or the extreme value. So now looking at this first equation, y equals x squared minus 2x minus 24, I know it's a quadratic because it has an x squared, and I also know that this is going to open up. So it's not going to be this one, it's going to be that one. Therefore, when it says state if it's a max or min, I already know before beginning the question that I'm going to get a minimum value. How I know that is that the coefficient in front of the x is a positive 1 because I can't see it. And whenever the coefficient of x squared is positive, it opens up. If it's negative, it opens down. But now I want to find that point. I'm going to start by looking for the zeros, sometimes called the intercepts or the roots. Those are the points where this U shape will cross the x-axis. So if the xy axis is drawn, the roots or the intercepts are those points. And the vertex always has to be halfway in between them. So how I solve this, the height on the x-axis is 0. So that's why sometimes they're called looking for the zeros. So I'm going to bracket, 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 x, x. I'm factoring this as a trinomial, which you learned in grade 10. So I look for two numbers that multiply to give me negative 24 and add to give me negative 2. So the numbers are negative 6 and positive 4. Doesn't matter what order I put those in, the positive 4 bracket could be first, but negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. So then my roots are positive 6 and negative 4. Why those are the answers is we're really taking each bracket separately and solving it equal to 0. Because if the first bracket is 0, 0 times the second bracket is going to be 0 and will work and give us the answer. X minus 6 equals 0, the x moves over and becomes positive. Similarly, I solve x plus 4 equals 0 because anything in the first bracket, no matter what it is, times 0 will give me 0 and will make this equation work. A lot of the times you don't see this step written down, but I wanted you to see where these came from. So now, if I were to think about graphing this, negative 4 is one root, positive 6 is the other. I know the parabola is going to come down like this because it has to open up. Now I want to find where that lowest point is. Because these are symmetrical or even, the vertex is going to always be exactly in the middle of the two roots. Now some people can look at that and say, okay, I know positive 1 is going to be the middle. Not a problem if you can't see that. You always just take your two answers and average them or find the middle by adding them up and dividing by 2. 6 plus negative 4 is 2. 2 divided by 2 is 1. So I know that the vertex is going to be at 1. So when it says give the value of the x that produces the extreme value, we've already done that. X equal to 1 produces the minimum or the vertex. Now I actually have to find that vertex. Well, the original equation is y equals x squared minus 2x minus 24. I'm going to see what happens when I sub 1 into that equation. I get negative 25. So I'm not going to count down. I'm going to go maybe 5, 10, 15, 20. Negative 25 would be about there. So that's what my parabola would look like. And pretend that it's even. It's easier on graph paper. Now, if you would have went to the factored form, y equals x plus 6, x minus 6, and x plus 4, you'd get 1 minus 6 times 1 plus 4, which is negative 5, times positive 5, which gives me negative 25. So it really doesn't matter which of these two equations you sub 1 into, as long as you do one of them. And negative 25 makes sense because that makes my parabola open up. So that is the min value. The y is always the value. The x is what produces that value. So we have a minimum, of negative 25 at x equal to 1. Now the last thing they want is for us to state the domain and range. Well, remember dx ry. Domain describes the x's, range describes the y. Now, when I describe the x's, it's not just the x's that I see. I can't say, oh, maybe this goes to negative 4 point something and 6 something. This graph, if it were drawn forever, would continue to widen. The parabola would get wider and wider and wider and eventually cover all the x's in both directions. So the domain of every parabola, if you memorize this, you never have any work to do. The domain is always all real numbers because the graph will spread side to side eventually. The range, though, there's a definite stopping point to this graph. This graph starts at negative 25 and only lives above it. There's no y values that are lower than negative 25. So the range is negative 25 and over. How we say that in math, because mathematicians are lazy, is y greater than or equal to negative 25. For this next one, our directions are the same. First off, I look in front of the x squared, and it's negative 3. I really don't care about the 3 right now. What I care about the negative. The negative means it opens down, therefore it has a max. Now I'm going to try and find the x that produces the max. I can't just go bracket, 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 bracket in this case because there's a number in front of the x squared. As soon as that number is anything other than 1, you can't go straight to bracket, 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 bracket. I'm lucky though because negative 3 comes out of all of those numbers. It's common. So I'm going to common factor it out. Negative 3x squared divided by negative 3 is just x squared. Positive 6 divided by negative 3 is negative 2, and that term had an x. Positive 24 divided by 3 is negative 8, and there's no x on that term. The negative 3 does not go anywhere. It just sits in the front. But now, because inside the bracket I don't have a coefficient on my x squared, I can do my bracket, 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 x, x, and I'm looking for two numbers that multiply to give me 8, negative 8, and add to give me negative 2. Well, negative 4 and positive 2 work. Negative 4 times positive 2 is negative 8. Negative 4 plus 2 is negative 2. So now my zeros are 4 and negative 2. Don't worry about that, that's nothing there. The negative 3 is there, but it doesn't impact my answer because negative 3 cannot magically change into a 0. It doesn't have an x or a variable. The only two parts that can become 0 are the brackets. So now my vertex is going to be halfway in between them. And it just happens to be 1 again. You can get numbers other than 1. So that's the x part that produces the maximum value. Now to find the maximum value, I'm going to go into this factored form. So instead of x minus 4, x plus 2, I did 1 minus 4, 1 plus 2. BEDMAS says to do inside the brackets first. And now this is all multiplication. So negative 3 times negative 3 is positive 9 times positive 3 is 27. It didn't ask us to sketch, but sometimes it's not a bad idea to put this information on just to see if everything works together. And it's just a sketch, so I'm not too worried about my scale. But yeah, negative 2 and 4 work as zeros. 1 is in the middle, and I already said it has to open down and have a maximum. So if I put a point at 127, I have my maximum. So the x that produces the maximum is 1. The maximum is 27. The domain, no thinking, all real numbers because it's a parabola. This parabola will eventually spread out horizontally. But the range is everything under or below 27 because the graph does not exist above 27. Well, how mathematicians say everything below 27 without having to write it is we say y less than or equal to 27. Okay, for the last one, I have a 4 in front, but it's positive, so I know it opens up, so I know it has a minimum. I look at the 4 and I say, okay, I'll deal with it because 4 comes out of 8, but 4 does not come out of negative 5, so I can't treat this the same way I treated the example B where the 3 came out. Now, in grade 10, you should have learned factoring by decomposition. That is how to deal with a number in front that doesn't come out. I went over this a little bit in the last unit, quadratic or just general functions, but I'll go over it again. So what we do is we take the first and the last numbers and we multiply them together. So 4 times negative 5 is negative 20. I'm looking for two numbers that multiply to give negative 20 and add to give 8. So it's going to be positive 10 and negative 2. This is decomposition, so I do not just put those numbers in a bracket. I literally take the 8 and I decompose it or break it down. Instead of 8, I'm going to do 10x minus 2x. Because then I just look at the first two terms and I say, well, what's common? 2 goes into the numbers and they both have an x. 4 divided by 2 is 2. X squared divided by x is x. 10 divided by 2 is positive 5. X divided by x is gone. Then I look at the second set. The only thing the same about those is a negative, and whatever sign is in the middle always comes out there. Negative 2x divide out a negative is positive 2x. Negative 5 divide out a negative is positive 5. And I'm pretty happy to this point because my brackets are the same. If the brackets aren't the same, then I've done something wrong. There's no number in front of this bracket, so I understand it to be a 1. I like to put it there because one bracket is 2x plus 5, the bracket that's repeated, and the second bracket is made up of the quantities in front, so 2x minus 1. So now this is a little bit different because again I'm looking for my zeros. I'm going to solve this equal to 0. So it's going to be 2x equals negative 5, x equals negative 5 divided by 2, or x equals negative 2.5. Again, in the last unit I talked about the trick opposite over, negative 5 over 2. So when I come over here, I could do this whole method again, or I can say, okay, opposite over. The 1's going to move over and become positive. Then I'm going to divide by 2, so I get 0.5. So in this case, my zeros are at negative 2.5 and 0.5, 0.5. I've exaggerated my scale a little bit so I could see them. If I want to find the middle point, because that's where the vertex will be, when I do that, I get negative 2 over 2. I get negative 1. So my vertex is going to be at negative 1. So there's the x that produces the vertex. To find it, I'm going to sub in. Now it doesn't matter which one you sub into, down here or up here. I'm actually going to sub into the top one just so I can review exponents, because I've noticed some people are struggling with doing math with exponents. So the first thing I do is sub negative 1 for all my x's. Now BEDMAS, exponents come before multiplication. Negative 1 squared is positive 1. Positive 8 times negative 1 is negative 8. Minus 5, I'm showing all my work. 4 times 1 is 4. Subtract 8, subtract 5 is negative 9. So if I make that negative 10, negative 9 will just be above it. In my sketch would look like that, which makes sense for me having a minimum. So this graph has a minimum. The x that produces the minimum is negative 1. The actual minimum value is negative 9. The domain is all real numbers because it's a parabola. And the range is y above or bigger than, starting at negative 9, greater than or equal to negative 9. So the domain of every parabola is always the same, and the range is always structured the same. It's always y greater than or equal to a number, or y less than or equal to a number, depending on the direction of opening. Okay, so now we will apply the same process but with meaning involved. So instead of just having an equation that's y equals x squared that will give us the graph of a parabola, we have h equals t squared because we're going to be launching a rocket, and h represents the height of the rocket and t represents how long it's been after launch. It's a negative in front of the t squared, which means this is going to open down, which makes sense. A rocket is going to have that kind of path, and the maximum height is going to be the vertex. So I start by taking the equation, and again I'm looking for my zeros because the vertex is always halfway between the zeros. And I know that the y-axis is going to be over here because it was launched from a cliff. So it was kind of already in the air at the starting point. I have a negative 2 that I can't take out, so I'm going to do decomposition. Negative 2 times 21 is negative 42. Two numbers that multiply to give me negative 42 and add to give me 1. The number in front of the t are positive 7 and negative 6. So I'm going to decompose or rewrite the t term in the middle as positive 7t minus 6t. Well, the only two things the same about the first two is there's a negative there and a t. So I'm going to take out a negative t because 2 and 7 don't have anything common other than 1, and I always take out the leading sign. So negative 2 divided by negative 1 is positive 2. T squared divided by t is t. Positive 7 divided by negative is negative 7. T divided by t is 1 or gone. Now I come to the next two and I have a negative in the middle, so I'm going to take that out. 6 and 21, 3 goes into both of them. So 6 divided by 3 is 2. I had a t and I couldn't take one out. 21 divided by 3 is negative 7. I know I'm probably on the right track because my brackets are the same. So one bracket is 2t minus 7 and the other bracket is negative t minus 3. So I'm going to do opposite over to get positive 7 divided by 2. So t equals 3.5. And I'm going to do opposite over to get positive 3 divided by negative 1 because there's a negative 1 in front of this t to give me negative 3. So one 0 is negative 3 and the other 0 is 3.5. To find the vertex, I'm going to add them up and divide by 2, which gives me 0.5 divided by 2, or 0.25. So after a quarter of a second, because that's a t, it's going to be at its highest point. Once I have that, I'm going to sub it in. It doesn't really matter. I think I'm going to sub into the top one. And definitely going to use my calculator to help me with some of these calculations. That's a 21. So I'm going to do 0.25 squared, 0.625 I think, 0.25 squared, yep, is 0.0625 plus 0.25 plus 21. Now I'm going to put the negative 2 in the bracket by going negative 2 times 0.0625, which gives me negative 0.125 plus 0.25 plus 21. And now I'm just going to add those up. So that plus 0.25 plus 21. So 21.125. So I have negative 3 back there, 3.5 there, 0.25 is going to be a little bit there, and this is 21.125. So the rocket is going to look like that. I like to put it on a sketch because now I can answer the question. Find the maximum height of the rocket. Max height is 21.125 meters. How long after launch does the rocket reach its maximum height? Very quickly. So it reaches it 0.25 of a second after launch, almost immediately. And how long after launch does the rocket, or sorry, when will the rocket land? Right there, because the graph keeps going. It assumes that the rocket's going to burrow into the ground. We know that's not going to happen. It's going to stop there. So it lands 3.5 seconds after launch.